9.4, Example 2. Before we dive into Example 2, there are a couple definitions and a theorem I need to go over. So the first definition says that if a sub n has both positive and negative terms, so maybe like sine of x or 1 over x plus 1, and the series of the absolute value of a sub n converges, then the actual series will converge as well. And we actually call this converging absolutely because we take the absolute value. So the theorem of absolute convergence implies convergence. So if we can show that something absolutely converges, then we've shown that the regular function converges. So the theorem says if the series of the absolute value of a sub n converges, then the series of a sub n will also converge. This is very useful when you deal with functions like sine and cosine or something that alternates, because you can get rid of that negative. So example 2, I want to show that the series from 0 to infinity of sine of x to the nth power divided by n factorial will converge for all x. So the first thing we're going to do is we're going to go ahead and write down our series. So we have sigma n equals 0 to infinity sine of x to the n divided by n factorial. Now, I need to show that that's less than something. So what I'm going to do is, since it alternates, that's kind of like your hint. If your function alternates, you might want to try using the absolute values to show absolute convergence. So what I'm going to do is I'm going to slap some absolute values around it, just for funs. Let's see what happens. So I can rewrite this as sigma n equals 0 to infinity absolute value sine of x to the n divided by n factorial. Now this is always less than or equal to, so let's think about what sine can be. Sine is always between -1 and 1, and so if you do the absolute value, it's guaranteed to be less than or equal to 1. So I get summation n equals 0 to infinity 1 over n factorial. Now this is the next really cool part, is I'm going to show you that this sigma, this summation right here, is actually just equal to the letter e, which is about 2.67 something something something. So I'm going to go ahead and run my factorial. So 1 over 0 factorial is 1. 1 over 1 factorial is 1, so 1 plus 1 is 2. 1 over 2 factorial is 1/2, so 1 plus 1 plus 1/2 is 2.5. And so on. If I let that run, we can see it levels off pretty fast. And what I'm going to do is I'm going to go ahead and graph y equals e. So that's this right here. And so we can see that the summation of 1 over n factorial is in fact 2.67777, which is e. So you're going to want to go ahead and memorize that summation. That's a very special one. I would write that down somewhere. Big bold letters around it. Do like one of these. Maybe throw one of these around it. Do like something like this. That should be stuck in your brain. Color it if you have to. Whatever you got to do to make sure you have that memorized. Okay, so now that we have all of that wonderfulness, we know that it's going to converge because, well, e converges because e is a number. Since the summation from 0 to infinity of the absolute value of sine of x to the nth power divided by n factorial is less than or equal to the summation of 1 over n factorial, and the summation of 0 to infinity of 1 over n factorial is equal to e, which converges, then the summation of sine of x to the n divided by n factorial will converge absolutely. Now on your own, I want you to show that the summation from 0 to infinity cosine of x to the n power divided by 2n factorial will also converge for all x. Okay, so what we're going to want to do here is first identify that the numerator changes from positive to negative. So a good tip for this one is to use that absolute value. So the next step we have to do is go ahead and bound it, and I'm going to say this is less than or equal to, well, for the numerator 1, because cosine of x is always less than 1. And here's the trick. You could write 2n factorial. Oh, I forgot my sigma. Okay, so that's good. So you have 2n factorial, but that's not necessarily e. So this is also less than or equal to sigma from n equals 0 to infinity 1 over n factorial. Because if we have this, this is equal to e. Therefore, I know it's going to converge. So since the summation of the absolute value of cosine of x to the n divided by 2n factorial is less than or equal to the summation from 0 to infinity of 1 over n factorial, and that summation is equal to e, which converges because it's a number, then we get that our original problem, the summation from 0 to infinity of cosine of x to the n divided by 2n factorial, converges absolutely.